Welcome back. In this lesson, I'm going to break down public and private subnets in AWS. By the end of this video, you'll understand how these subnets work, how they balance accessibility and security, and how they fit into your AWS networking setup. Let's start with the basics. A subnet, short for subnetwork, is a smaller section within a larger network. Think of a city where different neighborhoods make up the whole. Each neighborhood has its own set of houses, but they all belong to the same city. In AWS, a VPC, that is Virtual Private Cloud, is like the city, and subnets are the neighborhoods, helping to organize resources and control communication within your cloud network. In AWS, subnets fall into two main categories. Public subnets. These are designed for resources that need direct communication with the internet. Private subnets. These are for resources that should remain isolated from the internet and only communicate internally. Together, public and private subnets help design a secure and functional cloud network. Let's zoom in on public subnets for a bit. A public subnet is like the front yard of your VPC, open, accessible, and designed for resources that need to interact with users over the internet. There are a few things that make a subnet public. Resources in a public subnet typically have public IP addresses, allowing them to send and receive data from the internet. A public subnet is connected to an internet gateway, which acts as a bridge between AWS and the outside world. Now you might be wondering, what are some common examples of resources that could be placed in a public subnet? Web servers. If you're hosting a website, the server needs to be accessible to users worldwide, so it belongs in a public subnet. Another example is public load balancers. These distribute incoming traffic across multiple servers to ensure reliability and performance. Since they handle requests from the internet, they also belong in a public subnet. By default, any new subnet you create in AWS starts off as a private subnet. To make it public, you need to attach an internet gateway. I'll go deeper into internet gateways later, but for now, just think of them as the component that allows internet access. Now let's talk about private subnets. These are like the backyard of your VPC, hidden from the outside world and reserved for internal communication. Here's what makes a subnet private. No direct internet access. Private subnets are not connected to an internet gateway, so resources inside them cannot communicate with the internet directly. Resources use private IP addresses. These IPs are only visible within the VPC, meaning resources in a private subnet can communicate with each other, but remain invisible to the outside world. Common examples of resources placed in private subnets. Databases. Storing customer or business data in a private subnet ensures it's protected from direct access. Application servers. These process back-end logic and should remain secured from public exposure, while still interacting with databases and other internal services. With private subnets, you create a secure environment where sensitive resources are protected from direct internet access while still functioning within the network. Public and private subnets aren't separate entities. They work together to create secure and efficient cloud environments. Let's look at a real-world scenario. Imagine you're hosting a web application. The web server belongs in the public subnet, allowing customers to visit your website. The database belongs in the private subnet, where it remains protected but can still interact with the web server. This setup ensures that while users can access your website, sensitive data stays secure within the private subnet. But what if resources in the private subnet need internet access? For example, what if the database or application servers need to download security updates or connect to an external API? This is where the NAT gateway, that is Network Address Translation Gateway, comes in. The NAT gateway acts as a middleman between private subnets and the internet. It sits in the public subnet and allows resources in the private subnet to initiate outbound connections to the internet without exposing them to inbound traffic. This means private resources can download software updates, send data externally, or reach public APIs while still remaining hidden from outside access. Using a NAT gateway is a best practice for ensuring that private resources can securely interact with external services when needed. Now that you understand public and private subnets, the next step is to create them in AWS. In the next lesson, I'll walk through a hands-on demo where we'll set up a VPC with both public and private subnets. By the end of that demo, you'll see exactly how to configure your own subnets and how they fit into a secure cloud network. Thanks for joining me, and I'll see you in the next lesson.